Ladies and gentlemen, welcome everyone. I am Dr. Roland A. Drolet, PhD in Biomedical Engineering from the University of Toronto, 1971. I am the developer and inventor of the RUMART PEM system that has helped over 1 million people all over the world who were suffering from all kinds of health problems. My daughter Joseanne, part of the team since she was born. Hello everyone, this is the third video clip of the V series titled The Scientific Philosophy of Life and by Rhode Island University, and I have the pleasure to explain a few of these topics to my daughter Joseanne, and I have many pages to go through, so this is an introduction to many subjects. So if we have time, you could have a few questions afterwards, but probably we won't have much time because there are so many things to cover. So we start right away. This is called Universal Physics, Summary of 12 Concepts, referring to many pages. And here I have a subtitle, From EM Wave to Particle Energies to Lyman Forest. I don't know if you heard the term. The light band of hydrogen spectra that was discovered by Lyman. This is how they measure the distance of different galaxies. Okay, so are visible light fatigue? So I'm just asking the question because in the last century many people thought well, maybe it's just that light is fatigue and it changes frequency because of distance, but that's not the case. Yeah? Here, just getting started right away, I mentioned what I call the universal wave equation, which apply to any type of wave, whether it is sound, it is a wave on water, electromagnetic wave. The wavelength multiplied by the frequency give the unit of speed or velocity. Okay. Now this is totally, completely general wave equation and simple. The EM wave equation of electromagnetic, EM for electromagnetic, is wavelength of the rest vacuum or and the frequency of the resting vacuum, if you want, wavelength by frequency give the speed of light. And this is square root of 1 over mu 0 epsilon 0, mu 0 being the magnetic permittivity constant for the vacuum, and E0 is the dielectric constant of vacuum. Okay? So, and this is proven with one of the clips in the A series that I've done earlier, that automatically at resonance of a parallel plate capacitance or capacitor with the vacuum around it, if you have moving charge, it gives rise to electromagnetic wave that will travel at the speed of light. It knows nothing else than that in vacuum. Of course, in a medium, the speed of light will be different. Now, I call this Rhode Island wave equation is the resonant frequency of the vacuum. I was looking for the R, why I use R. It's for resonant frequency of the vacuum. I found out with my little model that it's simply the speed of light, or this thing, combination of mu 0 epsilon 0, divided by 2 pi Rho being the radius of one plate disk of a parallel plate capacitor. Okay, so But then I just realized, using the resonance frequency formula of the electric circuit composed of the capacitance and inductance, that I end up with resonant frequency. This is just a wavelength. 2 pi times the radius is the distance, the circumference around the parallel plate capacitor. So I realized that I get back the lambda resonance vacuum wavelength multiplied frequency equals C. Okay, so this applies for any size of parallel plate capacitors or capacitor imagine. So I realized that depending on the size of the space we consider and the separation of charges, that actually automatically we are in resonance with a specific frequency depending on the dimension. So that's interesting. That's where time is born from space. So don't worry, don't be surprised that Einstein arrived at space-time, because in general relativity, space and time cannot be separated. And I arrived at that with a simple equation. So that's interesting. De Broglie's particle wavelength, wavelength is Planck's constant divided by mass times velocity. But the equation of a energy of a photon, according to Einstein and Planck, it's Planck's constant times frequency. So if I take Planck's constant times frequency, I get, if I take mass multiplied by speed square, okay, here I get simply that the kinetic energy will be the sum of potential and kinetic energy. This will be only kinetics, but it's the sum of potential and kinetic energy that will be equal. So when we actually take the mass time frequency as being the frequency given by this equation, we end up that mvp squared. Why not the kinetic energy m times speed divided by 2? Because there is potential and kinetic energy. This is why. Einstein mechanical equation, this is what is called Einstein's equation. It's 1 over 2 pi multiplied by what I call the atomic spring constant divided by the atomic mass. Atomic time constant can be seen for a solid as Young's modulus multiplied by the elongation length, delta A. Einstein melting metal, it's when the thermal agitation, Boltzmann constant time to temperature in Kelvin degree, is equal to the phonon frequency. This is not photon. Einstein considered that little mass, atomic mass, vibrate with frequency like photons do. So multiplying this Planck's constant by the frequency, equating that to thermal energy, we can calculate actually the temperature in Kelvin degree when the energy will melt the metal, that the solid will become a liquid. Okay. Now, Bohr-Rydberg hydrogen atom. This is the model where Rydberg realized that if you add potential and kinetic energy as here with the equation of the electron going around the nucleus in the hydrogen, you arrive at this equation. A constant multiplied by hc, Planck's constant, speed of light, multiplied by 1 over n2, n being the main quantic number. Then this is the energy as a function of n, sum of potential and kinetic. But then if we consider a wave number 1 over the wavelength, that is the number of wave in a meter distance, he arrived simply at the equation from this one above, that it would be his constant would be 1 over nf, the final number, quantum number, minus 1 over initial number, and his constant was given in terms of 5 basic physical constants. But each of these constants can be measured individually. So this is one of the greatest results of classical physics, really, combining with atomic quantum concept as well. So for final number 1, 2, 3, or 4, Lyman series, we call from the Lyman forest to measure the distance of galaxy, Balmer, Paschen, and bracket series. So these are different series of absorption by hydrogen atom. So here we know the value of all these constants that have been measured, and here we go to page, to another page. So here we have a complement of measure number 5 that I call the measure of the Rydberg constant as a function of all these constants. So when we measure this with the spectrum of hydrogen, it gives us a way of showing that everything is coherent with our measure. So here demonstration, I demonstrate the actual value expression for Rydberg constant, which I've shown you earlier. So here you show that simply that potential energy or total energy of the photon rather is the energy of the initial state minus the final state is HFI going to F level, and this is the equation I've shown you in the other page. Since the energy of a photon is the potential plus kinetic energy, the energy of the electron in first approximation on a circular orbit is mv on the nth orbit divided by 2, kinetic energy, minus the potential energy, okay? So you just apply these, and where Rn, Vn is determined using the electrical force, the gravitational force between the electron and the proton in the hydrogen atom is really negligible compared to the electrical force. It's about 10 to the power 32 stronger, the electric. So when you equate the electrical force between the electron and proton to the centrifugal force, okay, you end up, and using de Broglie's equation for the wavelength of a mass, you end up that lambda m is 2 pi Rn. The wavelength is the circumference of the orbit, and this is de Broglie's equation, h divided by m Vm. And so you end up with, using this equation and this, you end up finding the radius of the nth orbit as a function of the constant and the speed here. So that putting this into this equation, you simply end up with this value of Ry, okay? So this is interesting, I say here. That's what we demonstrate. And the 5 experiments to measure these 5 constants are one for the electrical charge of the electron is the Millikan experiment using mini oil drop experiment between parallel plate DC voltage, and I've done that personally in my second year in physics at Laval University. The mass of the electron is determined by a magnetic field deflecting the electron, of which we know the charge, so we end up measuring the ratio charge to mass, so it allows us to calculate the mass of the electron, which is so light, about 9.11 10 to the minus 31 kilogram. And epsilon 0 is measured simply using a capacitor and knowing the dimension, okay? And SEL here is the surface of the parallel plate capacitor, dx is the distance between the plate, and E0 is the dielectric constant. H being measured from Einstein photoelectric effect, for which he got the Nobel Prize. That's where he got his Nobel Prize, not for relativity, but for this, because it was the proof that really photons behave as electrons, as waves. So there is a clip where I will show the simplified expression there. And C, the velocity of light, measured by Michelson-Moseley experiment, and Rydberg EM theory and Maxwell. Because from my simple experiment, I ended up with the velocity of light. Because the only thing that I used was the famous epsilon 0 and mu 0, and I realized that the electromagnetic wave that get out of there in vacuum cannot have any other speed than the speed of light. So in a way, I indirectly measure the speed of light, not having any trouble with big experiment, just parallel plate capacitor. So here I'm going to show you a few sheets, really many sheets, just showing in a little more detail what I was just talking about, okay? Without going into all detailed explanation, which are given in other clips or in the courses on scientific philosophy of life, those who want to go further. So this is about the electric capacity and inductor concept applied to atoms. So here I just show how this concept of capacitance can be applied to atoms, okay? Because you have a positive charge in the center of the atom, and the electron is negative. So using little tricks and using a distance between the two, being the radius, you can end up with different expression. Of course, this is not exact because I'm trying to apply classical theories to quantum objects. So that's it. So I'm going to show you other sheets. 2730. Okay, so this is plasma physics. This is just to show you that in microtube, for instance, with rings of carbon, okay, this is 6 carbon atom per layer, C6 ring. Okay, this is the kind of microtube in cells. Okay, and so when you have you consider the 7 millivolts difference between the interior and the exterior of the cell divided by the 100 angstrom, or 10 to minus 8 meter, you get an electric field of 70 millivolt over this length. That means 7 million volts per meter, which is much bigger, much higher than the high voltage tension. And we have this on all our excitable cells. Okay, this I have simply a note about UQAM physics department, plasma department. So here, this is simply showing equation from Einstein, Dirac, Bohm physicists to my own, where I have calculated really to show what Feynman called diagram Feynman since that time, showing what happens when two electrical charges hit together, or they meet together, then simply positive, negative charge, they won't get infinite speed, but they will get a certain speed, and using Einstein equation, Bowman, and my own simple equation, I arrive at what could be called the what ends up as Feynman's diagram, okay, showing what happens when two charged particles hit together, okay. So there is a whole book on this subject by Feynman, trying to explain to everybody, and he won a Nobel Prize with this Feynman diagram. He found a way to calculate what physicists could hardly calculate before because of the infinity that rise when a positive and negative charge hit together. What happens? You know, the force would become infinite, but a matter of fact is that they react, and if an electron and a positron hit together, it becomes two gamma rays perpendicularly. So this is experimental. So this is about the annihilation of matter and creation of matter with photon. So when I was saying earlier that matter and photon, they all interact, it's energy of different type. So here, induced magnetic alignment energy, I'm just talking about the magnetic alignment energy equation, which is the magnetic moment times external magnetic field. I have applied this to the Raumart different level of external field, okay? So they with 13 Gauss, 50, 100, 900, and I simply calculate the alignment energy with the basic equation. It's m times the external field times the what they call the magneton energy, or the Bohr magneton energy, which is 9.27 times 10 to the minus 24 ampere meter square. So this is a lot of detail, but this is just to show that there are magnetic field alignment there, and this is what happens when you hold a little magnet in the Raumart field. This is atmospheric pollution, realizing that what we call temperature macroscopically really is a velocity of molecules, okay? And the little equation there show from statistical physics the probable speed, the average speed, and the RMS speed of the molecule. But this depends on Boltzmann constant times the temperature, the energy, divided by the mass of the atom. This is how to show that depending on the molecule that you have, it will go faster or slower. So this is to show you, for instance, that why, for instance, NaCl at a molecule, okay, sodium chloride, why doesn't it go in the air? It's because the atoms are too heavy. But if you take H2O, the atomic mass is just 18 proton, okay? So it's one of the lightest molecules. Oxygen, it goes in the air too, it flies, it's 32. But when you get to O3, it's 48. You get to N2, different level. But then depending on the chemistry, on the um, type of bond between the molecules, it's not only the mass that determines where it goes. This is a simple introduction about the perfect gas law. Just showing the perfect gas law, pressure times the volume divided by temperature in Kelvin degree is the number of mole times the gas constant. Or pressure times the volume is simply the energy at a given temperature. Okay, you know that. So the number of molecule here, it can be seen as Na, Avogadro number, multiplied by Boltzmann time constant, which is I would say the thermal constant for the atomic level, and R is at the macroscopic level. So we know that gas constant R is 8.31, for instance, joules per molecule degree Kelvin. Okay, for moles, I would say. Na is the Avogadro number. This is measured simply with a simple experiment, and Kb, Boltzmann constant, is determined here by the gas constant divided by this. Okay, so this is 1 mole of gas at temperature and pressure, normal pressure, is 22.4 liters. Okay, in 1 atom gram there is Na atom. Okay, in 1 molecule gram there is Na molecules. For example, in 12 gram of carbon 12 there is Na atom, and so on and so forth. Okay, this is just a very. This is about elasticity and Young's modulus. I talked about it a little before. This is simply that the force is like the elastic constant times the distance, okay? And this is measured, let's say, with a rod. The Young's modulus is the force that is applied divided by the surface of this when it is going to break, okay? Now the elastic time constant, this is in Newton per square meter, but the elastic time constant is in Newton per meter. So this is why you have to multiply the elastic time constant by the elongation to get the unit of Young's modulus. And I'm not going to go in details of this, but this is what I talk about when I talk about the electron going around the proton. You have calculation of what we call ionization of the hydrogen atom simply by calculating the energy necessary so that the speed would get the escape velocity. So this again, it's classical mechanics applied to quantum system. Okay, donc this is a classical and quantum resonance using magnetic resonance imaging, and there is a something interesting realized that when people are being diagnosed with these magnetic resonance imaging using magnetic field perpendicular to a radio wave, for instance, they realized to diagnose cancer and this type of thing, a patient said that they felt good when they are there. So the people in Boston said, well, maybe one day, and at the MIT they said one day maybe we'll develop a therapy based on this. Well, this is something that we have for 35 years before them, which is called rumor. Okay, so anyway, here there are different type of ion cyclotron resonance, nuclear atomic spin resonance, different methods that are used for imaging, like in Boston. Frequency measurement, this is the thing that is measured most precisely from quantum theory and measurement. The frequency of each atom, a wavelength of 31 centimeter, is measured with an accuracy of 11 significative number about. Look at this. 10 to minus 11 hertz. Oh, plus or minus 10 minus 11 hertz. Okay? So this great precision is much higher than the theoretical precision. So that's interesting. Just a couple more pages. Ion cyclotron resonance, this is just giving a simple equation, classical, change of frequency when an atom is in a magnetic field, okay? So I won't go into all details of that, but this is classical theory of effect of magnetic field on atom, but this is more interesting. This is nuclear, atomic, and spin resonance with MRI imaging in USA and application to remote therapy. Contrary to classical theory, we have this equation. This is the angular frequency. This time here, G is what is called the Lange parameter with electric charge, the mass, and magnetic field. So anyway, the J factor of quantum mechanics, and I gave Segre as a reference in Nuclei and Particles book. So I gave the different value for the parameter. But this giving these concepts, we showed that from what they realized in Boston and magnetic resonance imaging and the quantum theory, we realized that there is a magnetic resonance at about plus or minus 4 Gauss when we use Raman. So that means exactly in the range where we have most physiological effect. So somehow I showed you a few of these things to show you that even quantum mechanics can explain why this type of amplitude of electromagnetic or physiological signal gave the result they gave. And we are in resonance there, on top of being in resonance with the synapse of the nervous system. We have a basic magnetic resonance at plus minus 4 Gauss, which is about 1/3 of the amplitude maximum when we use the maxi rings. So this is about 12 divided by 3 is about amplitude 4/3. So that's fascinating. So this is about it. Thank you very much.
Thank you.
And I wish that you enjoyed it. And it was a little fast, but it was not faster than you because you're fast. Okay, thank you very much. So that's the end of this clip. Thank you for your attention. I hope you enjoyed it. And please keep smiling till the next clip.